Yeah, hi guys, welcome to this YouTube channel. And as usual, in this channel, we are going to see the UGC Net Electronic Science related previous year questions. Okay, so if anybody of you are preparing for the electronic science UGC Net or else the set examination for the electronic science, then this videos or else this channel will be helpful. And if anybody are preparing for the net or the set electronic science examination or else any some kind of interviews related to the electronic science, okay, then I'm providing one course that is 1,000 previous year questions course. Okay, so whoever the interested candidates, that means this course is not yet started, which is going to start. So interested candidates may show your interest by WhatsApp to this provided number, that is 8639439984. So whatever the queries related to this course you are having, you just ask your queries and clear your doubts. And in case if you are okay with all the details, okay, and then you may take the subscription. And the course fee will be around 1,000 rupees. Okay, it's just like for each and every one question, it's 1,000 rupees. And this course will be really helpful to revise your concepts. Okay, whatever the concepts you studied. Okay, and with respect to the previous year questions, this course will be really helpful to crack the UGC Net Electronic Science examination. So I 100% suggest this course. Interested candidates may WhatsApp to this provided number. Fine. Okay. So in this video, we are going to see this question. All of you may read this question. Okay. So it is related to the unit number 1 as per our UGC Net syllabus. And it comes under the semiconductors related one. Okay. So here the given like a silicon sample is doped with the arsenic atoms, that is 10 to the power of 10 atoms per centimeter cube. And what is the equilibrium hole concentration at the 300 degree kelvins, means at room temperature. So whenever they are asking about the room temperature, you need not to go for the very big formulas and all. And you guys cannot expect also, okay, like other than the room temperature for the net examination. Okay. And they gave the intrinsic hole and electron concentration as like this. Fine. So the basic concept, I'm not going into the in-depth. Okay, so just the basic concept related to this question is that first of all the candidates has to know about the semiconductor. So basically there are different types of materials are available, but generally broadly we will classify as metals, semiconductors and insulators. Fine. And while coming to the semiconductors are having the property like depending upon the controlling elements or the controlling parameters, they can able to behave like metals, they can able to behave like an insulator also. Okay, and the semiconductors are divided into the two types based upon the dopings, and if it is not doped, then we will call this one as a intrinsic semiconductor. Okay, intrinsic is nothing but a pure semiconductor. And if it is doped with some materials, okay, or some atoms, then we will call this one as a extrinsic. Okay, the name itself it is telling that extra plus intrinsic. Okay, extrinsic means extra plus intrinsic. Fine. And in the extrinsic also depending upon the doping materials. That means if you dope the trivalent impurities, then we will call this one as a p-type semiconductor, p-type extrinsic semiconductor. And if you are doping the pentavalent atoms, then we will call this one as a n-type extrinsic semiconductor. Okay, and the examples of the trivalents can be taken as an indium and gallium and boron. Okay. So indium, gallium and boron can be taken as a trivalent impurities, and while coming to the pentavalent impurities, we can take as a arsenic, phosphorus and antimony. Okay, these are the different types of materials we are going to take. And coming to the trivalent impurities, boron is the most famous one, and coming to the pentavalent impurities, arsenic is the most popular impurity. Okay, so like this we are going to take, and in the p-type, actually the majority charge carriers we are going to take as holes, and minority charge carriers are the electrons. And while coming to the n-type semiconductor, majority charge carriers are the electrons and minority charge carriers are the holes. So here one concept all of you has to remember that even though in the p-type semiconductor majority charge carriers are holes, but while coming to the charge point of view, okay, either p-type or n-type, both these two are electrically neutral. What is the meaning of electrically neutral? That means in both the two cases, in p-type and n-type, both these two cases, the total amount of positive charge is equal to total amount of negative charge. Okay, that is called the electrically neutral. And you may get one doubt that if holes are majority charge carriers, then how come it is electrically neutral? So here the answer is that apart from the holes and electrons, ions also will be there. Okay, in the p-type semiconductor, the negatively charged ions will be there. And coming to the n-type semiconductor, apart from the electrons and holes, the positively charged ions will be there. Okay, so while coming to the p-type semiconductor, holes, right? Usually we will take as a P, hole concentration, electron concentration, and negatively charged carriers means acceptor ions. Fine. So now, while coming to the electrically neutral concept, total positive charge is equal to total negative charge, right? So positive charge comes from P, that is P is equal to electrons is having the negative charge and acceptor ions are also having the negative charge. And while coming to the n-type semiconductor, electrons, holes, and donor ions. If I apply the electrically neutral concept, then the total negative charge due to electrons can be taken as, that is n is equal to total positive charge will takes place due to holes and donor ions. Okay, it is a concept. Fine. And after going through the basic concept, while coming back to the question, here that they express that silicon sample is doped, right? So here, as per the mass action law in an intrinsic semiconductor, so if you take the energy band diagram of an intrinsic semiconductor, it is the conduction band and it is the valency band, and the Fermi level will lies exactly at the middle of this energy band. So if the Fermi level lies exactly at the middle of this energy band, then what it means is that concentration of electrons and concentration of holes, both these two are same. Okay, so that means N is equal to P is equal to Ni, intrinsic concentration. Ni is nothing but, fine. Now N into P can be taken as what? Ni square. And this expression is called as a mass action law. And here one wonderful concept is that this mass action law is applicable to both intrinsic semiconductors as well as the extrinsic semiconductors. For both these two it is applicable. And this mass action law is used to find out the minority charge carriers in the extrinsic semiconductors. Fine. So let's take the mass action law here. N into P is equal to Ni square. Okay. And here they are doping the arsenic atoms into the silicon. That means the arsenic atoms, as I already told you, that arsenic comes under the pentavalent impurity. Okay. So if I dope the arsenic atoms into the silicon, then it becomes the n-type semiconductor. Now I am taking n suffix n, p suffix n is equal to Ni square. I am converting this one into like this. Here the suffix n represents the n type. Okay, why? Because here in the question they are asking about the n type. So n suffix n and p suffix n. That means the number of electrons in n type, number of holes in n type is equal to square of the intrinsic concentration. And now here they mention, like, let's come back to this one. If it is an n-type semiconductor, that is n is equal to p plus nd, right, as per the electrically neutral concept. If I neglect the minority charge carriers in this expression, then I can write n is approximately equals to nd, right? So p is a minority charge carrier. If I neglect, then n will be approximately equal to nd. So now coming back to here, if I substitute nd in the place of nn, then nd into pn is equal to ni square. Now they are asking to find out the whole concentration at equilibrium. So now Pn, whole concentration at equilibrium, that is Pn is equal to Ni square divided by Nd, right? So Ni square, where the intrinsic concentration is given as 1.5 into 10 to the power of 10 whole square divided by Nd, that is arsenic atoms they mentioned as a 10 to the power of 10. And you have to remember one thing very strongly here. What's that thing is that here this one also atoms per centimeter cube, this one also atoms per centimeter cube. So you need not to scratch your head about the units. If it is in meters or else if it is in centimeters, then you need to work out on the conversion, okay, from one form to another form, right? So now coming to this one here, this one becomes into 2.25 into 10 to the power of 20 divided by 10 to the power of 10. Now here and here both these two cancels. Finally, we will get 2.25 into 10 to the power of 10, right? So 2.25 into 10 to the power of 10 per centimeter cube. So second option is the correct one. So it is how you have to solve this type of questions, and it is a basic concept you need to get, okay, to understand, rather than directly blindly applying the mass action law, right? So daily we are going to come up with previous year questions of the UGC NET Electronic Science. So whoever the interested candidates, so seriously preparing for the examination, so you interested candidates may WhatsApp to this provided number, okay, and I am going to start the 1000 previous year questions, okay, related to the electronic science. Either it is UGC NET or the SET examination. For both these two exams, this course will be really helpful to you. Fine. Anyway, thank you very much.